the oldest one. We'll neither study about the uh, latest one. The reason is oldest one is very old that there are, it's not a standard one to study. Okay, and the new latest one, why I will not study? Because it is very complex. Okay, so if I start teaching this one, you will feel like, sir, it is going out of head. Okay, and if I teach this, you will say, sir, this is not complete. Okay, so that's why you will find that in syllabus we have kept a microprocessor, which is a pretty standard one where you will understand all the basic concepts. Okay, so in the microprocessor part, I'll be teaching you 8085 microprocessor. Okay, so this is the one which we'll be teaching. Okay, which you will be learning. Okay, so I hope everyone has seen the first macro, first one. I hope yes. Have you seen this? This one have you
Yes,
seen?
sir.
I hope everyone has seen.
Yes, sir.
Yes, sir.
Okay.
Yes,
If
sir.
anyone has not seen, then let's see. Okay. So everyone has might have seen the CPU and all. I hope desktop and all everyone might have seen. So in desktop, if you have not seen, then you might be knowing about a term that's called motherboard. Yes or no? Everyone might be knowing that. So in
Yes, sir.
motherboard, you might have seen something called this fan kind of thing, which is always running. Whenever you switch on, the fan will start. Okay, even someone will tell that is CPU fan. Okay, so under this you will find this. Okay, and this is your processor. Is it clear? So if anyone has not seen, today is the best time. You can see it very clearly and just have a very basic pictorial view that what really a processor is. Okay. So still, if you have doubt, then now this might be clear to everyone. So this is your processor. Okay. Or you can say this is your processor. Getting my point? Okay. So now I can believe that everyone has seen a processor. I hope yes.
Yes, sir.
Okay, okay. So now I'm coming with a very interesting image. And can anyone tell me what is this? Can anyone tell me what is this? Okay, don't put a lot of pressure on your brain because this is something called as what? The internal view of the processor. Okay, this is the internal view. So frankly speaking, I am also not aware of these things. Just to make you little bit, just to create little bit interest, I have shown you. So the internal structure of any processor is very complex. Okay, so at this point of time, we won't be putting our, we will not be breaking our head and try to understand what is going on inside. Okay, so we'll just have a very basic idea. So I hope with this images, little bit idea you might have got what how the processor look like. Now let's see the definition part. Okay. Now this is really very important, and I want everyone to listen very carefully. I'll give you time to write also. Okay, because this is really the most important part. Now let's see the definition. So what is microprocessor? It is a multi-purpose, programmable, clock-driven, register-based, digital integrated circuit. Okay. So how many terms we have? Later on we'll see later on. Let's see till this part. What is microprocessor? It is a multi-purpose. Point number one. It is a multi-purpose. Second is it is programmable. Third is it is clock driven. Okay, and fourth one is it is register based, and fifth point is it is digital integrated circuit. Okay, so what is microprocessor? It is a multiprocessor, programmable, clock driven, register based digital integrated circuit. Okay, now you will tell, sir, the definition is very complex, but let me tell you, the thing which process the information is always complex. Have you ever thought of your brain, your own brain? Will it be complex or not? Yes, it will be very complex. Okay, so It is not that complex. If you just try to understand it, you will find it easy. Let me elaborate it. Okay. Now, what is microprocessor? It is used actually for multi-purpose. Means it can perform many tasks. You can go for addition, subtraction, multiplication, division. You can go for logical instruction. You can go for many kind of things. Okay. Means actually that is multi-purpose. Okay. Getting my point? Next, it is programmable. Programmable means you only told that if I connect a sensor, it will sense that sensor. Based on that, it will make some decisions. Okay, and then it will send some output. Yes or no? So this is only possible because of the programming nature. Okay, means a processor will contain what? Program, or if I say very specifically, it will contain instructions. Okay, and it will be executing these instructions only. Okay, and that's why it is called programmable. You can change the instruction, and when the instruction is changed, it means you have actually changed the job. Okay, next, third point is clock driven. Clock driven means, so actually in your processor, whenever it is processing will take time. Yes or no? I hope yes, you are getting my point. Whenever anything process, that processing will take time. Okay, so that time is actually, it will actually, time will be something like this. Okay, means you can say this is time t1, this is time t2, t3, like that you can say. Okay, so your microprocessor is clock driven. It means it will be based on the timing. Okay, means maybe at time t1, instruction I1 will be executed, and maybe at time t3, instruction I2 will be executed. Okay, so if it has been, it has, if the instructions are given that at time t3 I2 instruction will be executed, then at t3 only I2 will be executed. It is not like that it will execute earlier or after that. Okay, so that is the meaning of clock driven. Okay, next, register based. Register based means, see, your sensor, whenever your sensor is giving the information to the brain, that information will be stored inside the brain for a temporary time. Okay, and that is actually the register where your information is saved. Okay, I'll come regarding register based in more detail later on. Okay, and the last point is digital integrated circuit. Digital integrated circuit means a circuit which is digital in nature. Okay, that is your digital integrated circuit. So I hope these 5 points is clear to everyone. Just tell me yes or no, then I'll move forward. Otherwise, if anyone has any doubt in these 5 points, you can tell me now only. Is this 5 points?
Sir, can you explain again about the register base?
Okay, register based. See, I'll do one thing. I'll explain here. See, suppose this is your brain. Okay, now suppose I'll give you an example. Suppose someone is throwing a stone on you. So what you will do, if you have seen the stone, you will surely try to protect yourself. So basically what happened, through your eyes, you have sent an information to the brain. Yes or no? And then brain is processing that information, and then it is responding. Okay. So for processing any data, the brain should first of all store whatever is coming from outside, should store for temporary purpose, and then process it. Okay, so for storing part, we are actually using register, and that's why it is called register based. Okay, is it clear now?
Yes, sir.
Okay, any other point you can, if you have, you can ask.
Sir, digital
Sir,
integrated
digital
circuit.
integrated.
Digital integrated circuit. See, digital integrated means, first of all, you understand integrated circuit. Integrated circuit means what? An IC kind of. So if you have seen this, if you have seen this, so what is this? What is this? What are these all? These all are integrated circuits. Okay, and why it is called digital integrated circuit? Because it understands 0 and 1. Am I clear now? I hope I'm clear now. Digital
Sir,
integrated means,
sir,
Yeah, any other point which you have not understood? So I expect that everyone has understood. Now I'll move to the next part in this topic only, in this definition, that where I was, okay, digital integrated circuit that accepts binary data. You understand binary data? Binary means what? 0 and 1, which accepts binary data as input, okay, process it according to the instructions, okay, stored in the memory, and provide result as output. Okay, so you can say, if I uh, try to break this definition into two parts, the definition from here till here, it is what is microprocessor, and from here till here, it is what microprocessor is doing. Is it clear? So the complete definition is divided into two sections. First section is what is microprocessor, okay, and second is what it is doing. Okay, is it clear to everyone? So I will just request everyone to write this definition. Okay, I'm giving you 1 minute time. You just quickly write down the definition, and while writing you just keep in mind what you are writing. Quickly, all of you, just what, 30 seconds. Quickly write down, quickly. If anyone has any doubt, you can still ask. So I hope these terms are very, very clear to everyone. Okay, I hope everyone has written. So you can see this image also for better understanding. So what I said, microprocessor is what? It's a multi-purpose thing that already you have understood. It is programmable and clock driven. So you can see this is your microprocessor. Okay. Now this microprocessor is accepting input from outside world. Okay. And whatever it is accepting, it is stored in something. You can see it's written here accumulator. Okay. Or you can say this is your register. Okay, so whatever input is coming from outside is stored in register, and then after whatever is stored here, it is then there is something called control unit. Okay, what this will be doing, it will be seeing whatever input has come. Based on that, it will tell the ALU, arithmetic logical unit, to perform the task. Okay, and whenever when the task is performed, it will then send the data outside. Okay, so if I say in a very basic way, the control goes like this. From input will come here. Okay, control unit will get the information that input has come. Now control unit will decide that whatever input has come, for that what has to be done. Okay, so whatever has to be done, for that program might be loaded in the memory. Okay, so it will see the program and then understand what has to be done. Based on that, it will tell the ALU to perform the task. Okay, and again it will receive the control back. Okay, and then as per the program, it will send the data outside, or it may store back inside the register, or it may store back inside the memory. Okay, is this clear to everyone? I'll repeat once more. Just have a look what I said. This is your processor. Okay, so what it does, it will accept input from outside, which will be stored in register. Okay, so as soon as some data will come inside, the control unit will get the information that something has arrived. Okay, and In the meantime, there will be some kind of instruction present inside the memory, okay, and control unit will check this instructions, or you can say program, and based on whatever has to be done, it will tell the ALU to do that, okay. And once ALU has performed all the tasks, it will again receive the control back from ALU, and then it can do many things. It can send back the information to memory, it can send back the information to register, or it can even send back the information to the output device, okay. So depending upon what was the task, the control unit will be performing it, okay. Is this diagram clear to everyone? Tell me yes or no. Yes or no?
Sir.
Yes.
Yes, sir.
Okay. So I will give this PPT in your Google Classroom. You can check it from there, and make sure that you have understood this diagram. Okay, because these kind of diagrams are really very important in the coming exam. Okay. Next, there are some more points which is important. That is, it is a electronic chip. Okay, already I told you, and basically this processor is the main part. What is it is? It is also called the central processing unit of any computer. Okay. Now, in the second part, this microprocessor can be divided into two sections. One is called the word macro, which means small in size. Okay. And processor means what? Processor means a device that process or manipulates numbers, generally 0 and 1, according to the instructions stored in the memory. Okay. Read once more, I'll tell you. Macro means small in size, and processor means a device which can process or manipulate numbers, generally zeros and ones, according to the instructions stored in the memory. I'll give you an example. Like suppose in your register 5 and 7 is stored, okay, and the instruction is addition plus, okay. So what this processor will be doing, it will be understanding it as 5, and it will understand this as 7, okay, and it will see in the memory what instruction is given. So instruction given is add. So what it will do, it will add these two numbers, and it will give you the result as 12. Okay, so that is the job of a microprocessor. So this data which you are seeing, this data can be anything, okay, but keep in mind this data will be generally binary only, okay. Like if you look at any data at topmost surface, it may not look binary, but internally it is binary only, okay. Like you might be listening music, or you might be listening you might be watching movies. So this movie and music also are binary data, okay. So this all, anything stored in computer is binary only, okay. So this all data, as per the instruction given by the your program, the processor will be processing the task, okay. So this is about your microprocessor, okay. And it can deal with both combinational logic as well as sequential logic, okay. This we'll see later on while we will be doing, while we'll be understanding microprocessor, that 8085 microprocessor, okay. This was the very basic idea regarding what really a microprocessor is, okay. Now moving to the next point, let's see some examples. So you might have heard of, or can anyone tell me, what do you think, mobile phone is having a microprocessor or not?
Yes, sir.
Yes, sir.
What about this? What do you
Yes,
think?
sir.
Yes. What about this?
Yes.
Yes.
Sir.
Yes, sir.
Yeah,
Computer
right.
also.
Yeah, computer also. And I mean, whatever example I'm showing you, if you feel that it is not having, then you are wrong. Okay. They all are having some kind of small processor inbuilt inside them, so that it can perform some task. Okay. Next, it has advanced applications also, like in radar, in satellites. Here also you will find the microprocessors. Okay. Can anyone tell me some other example? Any other example? Can anyone tell
Different
me?
examples are mainly Intel cores, Intel Pentium,
Or
Intel Atom,
you
Intel
are telling the name,
808, and
you are telling the name of microprocessor company. I'm talking about
yes,
some devices
no
where
sir,
microprocessor is used.
Robot, sir.
Robot. Okay, great. So let's see some
CNC
examples.
machines.
So these are the examples where you will find the microprocessors. Okay. So whatever image you are seeing, whether it is washing machine or it is your camera or it is your laptop or see this is what? Which machine is this? CT scan you might have heard of.
CT scan.
Yeah, yeah. You might have. Okay. So what this girl is doing?
Treadmill.
Yeah, this also is having a processor.
Treadmill,
Okay.
sir.
Yeah, this also is having a processor. This also is having a processor. Everything, whatever you are seeing here, okay, everything is having a processor. Okay, so maybe it's a small processor or it may be a huge processor. Okay, but we are concerned about whether it is having a processor or not. Okay, so whatever is having some kind of sensor organs or it is showing some kind of output, surely it will be having some kind of processing part as well. Okay, so if I say or if I give you one task like uh, from your branch, find out 10 devices where processors are used. Can it be? Can you all do?
Yes sir.
Okay, so if today only I'll post a small question, and if you have answer, you can put in the comment only. Okay, so let me see who all are responding. Okay, so we'll see that. It's not a like I mean, if you are not putting, you will not get marks. Not like that. Just a idea of interest. Okay, that whether you are getting aware of your topic, which is getting related with your branch. Okay, that's why I've given this question. Okay, the question is from your branch, can you find out 10 devices where processors are used? Okay, so let's see who all are responding to my question. Now coming to some history part. So we have microprocessors, which was, you can see it started, I mean, this is the first one which was, you can say, a bit successful one. And before this also there were many microprocessors, but they were not successful one. Okay, and that is called 4-bit microprocessor. So we have family of 4-bit microprocessor, we have family of 8-bit microprocessor, we have family of 16-bit microprocessor, we have family of 32-bit microprocessor. Okay, and even we have 64-bit microprocessors and 128-bit microprocessors. Okay, so what you will be remembering is in the microprocessor there are family of microprocessors, and their family is like 4-bit, 8-bit, 16-bit, 32-bit, 64-bit, 128-bit. Getting my point? This is family of microprocessor. Now someone might be getting a question, sir, what is this? What numbers you are writing here? What actually the number mean? Okay, so listen very carefully what this number mean. Okay, so 4-bit microprocessor means what? This processor is capable of executing numbers of 4-bit binary, or I can say like this, of have a look. So if I want to add 5 plus 6, so what is 5 plus 6? It is 11. Everyone knows that. Okay, but let me see how this processor will be doing that. Let's suppose this is a 4-bit microprocessor. So 4-bit microprocessor means 5 will be written like this. Okay, 4-bit microprocessor means it will write everything in a 4-bit. 6. So this is 6. Yes or no? Now it will add it and it will get what? It will get some information which will be either 4-bit or it will be 8-bit. Okay, getting my point? So 4-bit microprocessors are those microprocessors whose input will be 4-bit, 4-bit or less than 4-bit, and it will be capable of processing these datas and generate the result in either 4-bit or 8-bit. Okay, similarly if I say about 8-bit, there will be 8 bits. Okay, there will be again 8 bits. Fine, and we can perform some kind of operation like multiplication, division, or whatever you want. And the result, whatever you will be getting, that will be either 8-bit or 16-bit. Getting my point? Okay, so the result will be either 8-bit or it will be 16-bit. Okay, so I hope this point is clear to everyone. Just tell me once if you have yes got the point or not. Is this point clear to everyone? What do you mean by 4-bit processor, 8-bit processor, 16-bit processor? Is this clear to everyone? Guys, is this point clear to everyone?
Yes, sir. Yes, sir.
Yes?
Yes, sir.
Okay, okay. So this is a really very important question. See, I told in starting only that what is important. So this question may come in exam. Okay. So what do you mean by 4-bit processor? What do you mean by 8-bit processor? Okay. What are these bits actually? This is actually giving you an idea that the processor will, whatever processor will be executing, it will be executing based on these many bits. Okay. I hope this point is clear to everyone. Okay, so now let's move forward. So one small again task I can give you. Let me see if you can do that also. That is, I want everyone to find out some examples. Means example of 4-bit processor, example of 8-bit processor, example of 16-bit processor. Okay, so this is your second question. Let me see if you can give a try. That is examples of 4-bit processor. So you can find out 2 to 5 examples of each one of them. Okay, so give a try, all of you. Examples of 4-bit processor, 8-bit processor, 16-bit processors. Okay, and some examples regarding them. Okay, so that will be enough. So in this topic, what you have to understand, what is the meaning of this and examples. Okay, so if any question will come from this part, you have to tell what is this and examples. So if you just explain what is this and if you are not giving example, some marks will be deducted. Okay, so examples are again very, very important. Okay, so okay, now this is the again very important part. If you are not aware of microprocessor, now you will be surely aware of. So if you remember what I said, microprocessor is something which is having a control unit structure. It is having ALU, it is having register. Okay, so let's see what are the basic parts of a microprocessor. So the basic parts of a microprocessor are ALU, register, control unit, and there is one more. Can anyone tell me which is the fourth one? Can anyone guess and tell me which is the fourth one?
Memory, sir.
Okay, memory.
IO device.
IO device.
Memory.
So one of your friend is saying IO device, one is saying memory. अभी कोई एक और नाम बोल दो, यहाँ सिस्टम बस भी लिखा है और तो कोई नाम दिख नहीं रहा है मुझे. So
Sir, power unit.
पावर यहाँ नहीं है, पावर यूनिट ऐसा कुछ नहीं, पावर यूनिट.
Sir, input output units.
Input, okay, one of your friend told input output unit. So listen very, very carefully. ना input output unit है, ना memory है, it is actually system bus. Okay, so listen very carefully. I'll repeat once more. Any microprocessor will be having a control section. It will be having a section where arithmetic and logical information will be processed. It will be having some registers where temporary data can be stored, and it will be having a channel through which you can connect your output device, or you can connect your memory, or you can connect anything. Okay, I'll write here. Anything. Getting my point? So if I say once more, and I request everyone to write also. So what is microprocessor? What are the main parts of microprocessor? Control unit, ALU, register, and system bus. Is this point clear to everyone? Tell me yes or no. Tell me yes or no, guys. What are the main components of microprocessor?
Yes,
Now, let's see an example that, why we have only these four parts. Okay, so let's take an example. Suppose I want to add two numbers, 2 and 5. The job is plus. Okay, I want to perform this. So this 2 and 5 will come inside microprocessor, then it has to come through anyway. So the requirement of system bus is very important. Okay, without system bus, there is no microprocessor. Okay, it is something like this. Suppose करो तुम्हारे brain से जितना है वो सारा काट दे, brain कुछ काम करेगा क्या? नहीं करेगा. Okay, so similarly you can say the system bus is actually channel through which you can connect I/O devices, you can connect so that the microprocessor can interact with the device. Okay, so this system bus is very, very important. Okay, so if it is a 8-bit microprocessor, then in system bus you will find 8 channels. Okay, or you can find 16 channels. Getting my point? So if it is a 8-bit microprocessor, you will find 8-bit channel or 16-bit channel. Okay, we'll see in detail later on. So these numbers 2 and 5 will be flowing inside. Okay, and whatever is coming inside is getting stored in register. If you remember the definition, a microprocessor is register based. Yes or no? So what do you mean by register based? A register based is a place where data is stored temporarily for processing. Okay, so if the processor has to process any data, it has to store for temporary purpose. So this 2 and 5 will come inside the processor and it will be stored in some register. This 2 and 5 will be stored somewhere inside the register. Okay, then the control unit will pass this data to ALU. The ALU will perform the job of addition. Now, how it will perform the job of addition? This program will also be stored in some memory, and that program will also come from this side. Okay, and again this program will be also stored in some register. Getting my point? So program as well as data both will be coming inside the register, and this control unit will read that program, and based on whatever has to be done, it will keep on instructing the ALU for doing some job, and the ALU will perform the operation and it will send back the data back to register, and from register only the data will flow out. It can go to any output device, or it can get stored back in RAM or RAM, or it can be displayed directly to some other thing. Okay, so in this way your processor works. Okay, so I hope this point is clear to everyone. The block diagram. So in the block diagram, this is actually your processor. Is this clear to everyone? Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. So I request everyone that you should keep this diagram in your brain always, because later on when I will move forward, if this diagram is not clear to you, you will again have a lot of confusions. Okay. So you can treat this example with yourself, your brain, that your brain, if it is not having the control section or these sections, it will not work. Okay. Now, if you have understood, let me see, can you guess those 4 sections here? What were the 4 sections? Register, control unit, system bus, and ALU. There were 4 sections. Yes or no? So can you all guess? So basically this is the block diagram of 8085, which we will be studying in detail. Okay, and few of you might be thinking, sir, we have to learn by heart. Yes or no? I hope yes. So those who are planning to learn by heart, if you look and listen very carefully to me, you will not have to learn by heart. Okay, I'll just show you how. So whenever you see any diagram of any processor, you have to first of all search those 4 parts. Okay, So first part was system bus. So if you look carefully, your system bus is something this. Okay, so you can see here it's written here data bus. Okay, and this is your bus. Okay, now there was something called control unit. So can you see control written here, control circuit kind of thing is written here, control. So this is your control. See, control is written here also. Yes or no? Here also control is written. So these three are your control sections. Okay. And if you look carefully, this control section is connected with what? Bus. Okay. So from here, the data will be flowing towards the control unit. So this we will understand later on what is this. Okay. But for time being, you understand the from bus, or you can say system bus, these all the three control sections will be connected. Okay, now two more parts are left. What is that? Can anyone tell me?
Register.
Yeah, register. Can you see
ALU and
register written
register.
here? See, register is written here. Can you see?
Temporary register.
Yeah, register is written here. Okay, so these are some register names. Okay, so we'll come in detail. What are these registers? Later on, we will come to know. So this is your register section. Okay, and the last one is ALU. So ALU and its parts. Okay, so this is your fourth part. Okay, so if everyone can see, this is the first part, system bus. This is your second part. Second part is divided into three sections. This is your third part, and this is your fourth part. Okay, now I hope the diagram is little bit easy for you. I hope yes.
Yes, sir.
Yes, I hope yes. So if you
Yes,
have,
sir.
if you have no need to remember anything here. Okay, don't remember, don't learn by heart. I will explain you this complete diagram in such a way that you will feel that there is nothing to remember. Okay, why? Because everything present here is logically present. Okay, so why I am saying like that, you have understood from the small thing that is for any microprocessor I require four parts, and that four part I have shown you. Okay, so this small logic, if it is clear to you, in next classes we'll come to this topic once more, this diagram once more, and I'll explain you each and everything in detail. Okay, so before understanding these all, we'll understand what are these terms actually. Okay, so after understanding all these small terms, we'll again come back to this diagram, and I'll explain you what really this diagram, how this diagram is actually working. Okay, so with this, I am just ending up today's section, today's class. If anyone has any doubt in any of the slide, you can ask me. If anyone has any doubt in any of the slide, ask me. I'll explain. Is there any doubt? If you have doubt, you can write in the chat box. I'm ready to answer. In the meantime, I will take the attendance also. So I'm stopping the presentation part. Okay. If anyone is having any doubt, you can tell me. I'm waiting for you all guys. If you have any doubt, you can ask. So was the topic clear to everyone?
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay. Fine.
Yes, sir.
Yeah. If anyone has any question, you can ask. No questions. So all of you write down the two questions which I told you. What was the first question? Can anyone tell me? What was the first question?
Devices in our department having or using
Not
ICs.
ICs.
Microprocessors.
Yeah, using microprocessor. Yeah. So
Microprocessor.
let me in the Google Classroom you have to answer. I'll write down this question. Okay. What was the second question?
Uh,
Sir,
examples.
examples of 4-bit, 8-bit, and 16-bit ICs.
Yeah, that was the second question. So you can go for either 2 example, 3 example, or 5 example. It's up to you. But from every section, you have to write some examples. Okay. And I hope you have also written down all the important points I told you. I hope yes.
Yes, sir.
Yes, sir.
Yeah. So guys,
Yes,
yeah,
sir.
keep that in mind. See, you will, if you follow this, surely when the exam will come, you will feel that I have secured more marks, because I will keep on telling you all the important questions which may come in exam. Okay. So if you just follow those things, you have to just study those parts only. And if you cover that part, that is more than enough. Okay. So I hope it's clear to everyone. So
Sir, just
yeah.
share this PPT, sir.
Yeah, sure. In the Google Classroom, just now I'll post the PPT, okay, and you can see it. Okay, just if you just wait for 1 minute, I'll post it. In the meantime, if anyone is having any doubt, you can ask. So this is section A, group A2, na?
Group A2.
Yes, sir.
Okay,
Yes,
okay.
sir.
Yeah, I got it. Just wait for 1 minute and you will receive the PPT. So in every class, what I will do, I'll send you the PPTs, I'll send you the questions as well. So if you keep on replying the answer questions, surely you will understand it. I mean, you will not be having any doubts and all. Okay. So just wait for next 1 or 2 minutes, and I'm posting it as a material. So topic is basics of microprocessor. So I have given two questions. First one is some examples. Second, I'm giving you third question also that you have to check out while in the Google Classroom. Okay. Examples of devices containing what? Microprocessor, containing microprocessors from mechanical department. Okay, just next 30 seconds you will be receiving the PPT as well. Check your mail. Have you received the PPT? I hope you have received. Check it out,
Yes,
all
sir.
of you. Yes. So I have added one more extra question also there. There are 3 questions. Okay. So it's up to you now.
No, sir.
Check carefully and to try to answer it. I hope it is visible to everyone. Okay, if it is not visible, we'll see later on. So now I'm winding up the class. I hope no one is having any doubt. Okay, guys, thank you for attending the class. Check out the Google Classroom. You will get the PPT and you will get 3 questions there. So whatever answer you feel,
Received, sir.
yeah,
Yes, sir. Got it.
what
Yes, sir, we
yeah,
got it.
Sir, received, sir.
yeah, every day I'll keep on posting like this only. Either you will post just after
Got
the
it,
class,
sir.
just after the class I'll post, or by night I'll post. Okay. So
Okay,
you can see there are 3
Okay,
questions also. Kindly try to answer as comment only there itself. Don't post anywhere else. You have to post your answers as comments. That's it. Okay. And
Okay, sir.
these all comments will be very beneficial to you when you are revising. Okay. So keep on doing that. Okay. So thank you
Yes,
everyone
sir.
for attending the class. Let's meet in the next day. I think next class you have on Wednesday. Yes or no?
Yes, sir.
Okay, fine. So let's meet on Wednesday. Fine. Thank you, everyone. I hope your doubts are also
Exam.
clear.
Thank you, sir.
Attendance.
Yeah. Thank you, everyone.
Sir, attendance.
Yes, sir.
Thank you, sir.
Attendance I have taken automatically. Is that okay?
Attendance automatically, yes, sir.
Yes, sir. Okay, sir.
Okay, sir.
Thank you.
Attendance I'm taking automatically. Okay. I'm using some software. With that software, I'm able to take the attendance automatically.
Okay, sir.
Is it clear?
Okay, sir. Okay, sir.
Not like that. Only everyone
Okay,
can
sir.
ask you. Okay. So I hope that is okay. Okay, fine.
Okay, sir.
Thank you, everyone. Thank you,
Yes,
everyone.
sir.
Thank you, sir.
Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Good night. Good night.
Good night. Good night.
अबे चिन्मय हेलो कोड पाइलु बेसी
Good
येटा
night,
पीडीएफ रा
सो जा
कल मिलते हैं, बाय।
पीडीएफ रा कोड पाइलु
All of you, bye.
पीडीएफ रा कोड मेल तो आसिन
के जाने मु तो पाइनी मु समान कहले मु खाली हां हां मैं
Google Classroom
मेल राष्ट्रीय
क्लासरूम रे आसला और मेल रे आसे क्वेश्चन आते
ऑफिसर टीम राष्ट्रीय
असला
लीड आए राष्ट्रीय
हां
कोथरे चेक करू रे आप रे
ऑफिशियल
मेल रे आसे और क्लासरूम रे जो जॉइन करना के
मेल नोटिफिकेशन आसीबो रे असला वाली
अबे मेल आईडी को सेंड
लीड आए राष्ट्रीय अरे फोन रखो तार बक्का अरे डाटाबेस तो
हां मेल आईडी आसीनी रे
हां रे बक्का ठीक
क्लासरूम रासला
हाउ रोज